What's up, calculus students? It's cold outside. I gotta sit in the sun. Do our first lesson, Unit 4. We're pretty much reviewing everything from previous units, only using e to the x and log x. What's the key to e to the x is that its slopes are equal to itself. So the slope equation of e to the x is just e to the x. You can figure out how quickly the function is changing, plugging in the x value into the slope equation. What do you know about e's and logs? They undo each other. So I'm asking you to write a couple statements so you remember the interpretation of what you're finding. You would say f is increasing 2 y's per x at x equals natural log of 2. Cool. What if you have e to the x over 6? Don't forget that constant 6 can be pulled out. So it's a 1/6. Constants don't affect things. You just leave the constant. Constants stick around unless they're by themselves. So the slope equation of this is just 1/6 e to the x. So if I plug in 2 log 3, this one's a little bit tricky, I can tell. You're not allowed to simplify this to be just 3. What we have to use is an exponent rule to say this is e to the log 3 squared. You have x to a power. You can write that as a power to a power. So x to a product of power. You can write it as power to a power. I'm going to write this as e to the log 3 squared, which means we actually end up with 3 squared, which is 9, which is 9/6. 9/6 is 3x. Oh. All right. Don't forget about the chain rule. Well, the chain rule shows up with these functions in a different way. We don't really see parentheses. We have to kind of know that they're there. We have e to the power, e to the parentheses as the outside, and their slopes are e to the parentheses. So the slope equation for g would be e to the, what starts in the parentheses stays in the parentheses, times the slopes of x over 3. Remember, that's just 1/3 x, whose slopes are 1/3. If I plug in 0, I get e to the 0, which is 1, times a third, which is a third. What is g double prime? Well, if g prime is 1/3 e to the x over 3, that constant sticks around. You could consider it as part of the outside. Again, you have 1/3 e to the power. You have this e to the power. You have that 1/3 stick around. And then the slopes of that are that. The slopes of x over 3 are just 1/3. And when you multiply together, you get 1/9. You plug in 3, you get 1/9 e. What is the interpretation of this value? This is the second derivative. Sorry. Second derivative tells me about the first derivative, which tells me about the original function and its curvature. So we would say that the slopes of g are increasing e over 9 y's per x at y's per x. So the slopes are y's per x. So how are my slopes changing? That's how my y's per x are changing per x. It's y's per x squared at x equals 3. Or you could say g is concave up at x equals 3. Two statements. Cool, so that's the chain rule with e to the x. If we take any other function, like x times e to the x, e to the x over x plus 1, don't forget your other rules. This is a product. You gotta use the product rule. Reminder, you don't have to do the entire homework. I'd rather you do part of the homework and just know what's going on. So the slopes of this are just 1, not 0. If you took the slopes of x times e to the x and did not use the product rule, you probably would have got 0. So make sure you use the product rule. Here, make sure you use the quotient rule. Slopes of the top times the bottom minus the slopes of the bottom times the top, all over the bottom square. Plugging in 2, I get e squared times 3 minus e squared over 3 squared, which is 9. That's 3e squared minus an e squared. That's 2e squared. I think a lot of people need to just practice like simplifying e's and stuff like that. You'd say at, or you'd say r is increasing 2e squared over 9y's per x at x equals 2. Okay, what about this guy? Well, this is a chain. It's an O and an I. So e to the power, negative x's slopes are negative 1. It's a very common one, e to the negative x, making sure you know the slopes are negative e to the negative x. Very common one. What about this? Well, slopes of e to the power, but for 4 over x, make sure you understand that's 4x to the negative first. It's been a while since we've done one like that. So negative 4x to the negative second would be the slopes of the inside. So that's c prime, e to the power times the slopes of the power. And c prime of 2 would be e squared times negative 4 over 4, which is negative 1, so it's negative e squared. We'd say c is decreasing by negative e squared y's per x at x equals 2. Cool, equations of tangent lines. Remember, we need a point and a slope. Plug in x, get a y. Find the slope equation. Plug in x, get an f. It's nice to be able to see it, so I'm going to graph it. There's 4 to the x. Y minus 2 equals 2 log 4 x minus a half. Why is this curving? Weird. Very weird how it treated that. All right, well this is it. So parentheses, I guess, when you're using Desmos, but there's that equation of the tangent line. We have the point 2 comma, or a half comma 2, and we have the slope 2 log 4. Fits perfectly. Let's do it with 2 to the x at 3. Plug in 3 to get a y. Minus 8 equals, windy. Y minus 8 equals the slope times x minus 3. Let's find the slope. Well, the slopes of 2 to the x is 2 to the x times the natural log of 2. Remember, numbers to power just have a different rule. We're not using the power rule. It's its own rule. And e to the x's slopes are e to the x times the natural log of e. But e to the x, or the natural log of e is just 1, which is why we don't put the natural log of e. But if I was taking any number to an x, the natural log of that number is not going to be 1, so we need to take it into account. 8 log 2. Cool. We can see that if we want to. Okay, 4 to a power is the outside. The inside is power. So it'd be 4 to the power times the natural log of 4. So that's kind of new, seeing this 4 to a power times the natural log of 4. So I have 4 to the x over 4 times the natural log of 4 times the fourth. That's a lot of 4s. Plugging in 2, I get 4 to the 2/4, which is 4 to the 1/2. So j of 2 is 4 to the half, which is 2. It's not plus or minus 2, it's just 2. So we get y minus 2 equals the slope times x minus 2. We need our slope of j at 2. So that's 4 to the half, which is 2, times the natural log of 4 times a fourth. So that becomes half, or log 4 over 2. I multiplied the 2 and the 4 together to get a half. Let's see this. Log 4 over 2. Ba-bam! Beautiful. Beautiful. Okay. Heads up, careful. Sometimes you're going to have multiple rules involved. Big star on this one. Multiple rules. We got 3x e to the negative x squared. Slopes of the first times the second. Plus slopes of the second. I got to use an O and I for slopes of the second. I got an e to a power and a negative x squared. This one you really have to do in practice. Slopes of the second will be negative 2x times e to the negative x squared times the first is a 3x. So I got 3 e to the negative x squared plus, I can go ahead and multiply the 2x and the 3x together. Then I can plug in 1. Okay, plug in 1. You square it first, then take the opposite of it. This order of operations is 1 squared, make it negative. A lot of people make mistakes on that. So I have 3 e to the negative first minus 6 e to the negative first. That's negative 3 over e. Cool. I also have to find h of 1, which is 3 over e. So my equation is y minus 3 over e equals negative 3 over e, x minus 1. I'm not going to graph that. Cool. Don't forget, power rule still exists for x to the power. Don't forget, constants go away unless they're attached to an x. Don't forget, you need a point and a slope. There's my slope. Here's my point. Y minus 9 equals 9 log 3, x minus 2. All right, another product rule of the chain. It is so pretty out here. Slopes of 5e to the negative x. You can use an O and I, or you can just figure it out. How's it going? Slopes of the first times the second, plus the slopes of the second times the first. I get just 5. That's the slope. If I plug in 0, I get 0. All right. Table problems. Taking the derivative of e to the f of x. Well, guess what? That is not e to the x. That's e to a power. Whose slopes are e to the power. And f of x slopes are f of x slopes. What is the derivative of g? G's derivative is e to the f of x times f prime of x. G prime of 2 is e to the f of 2 times f prime of 2. F of 2 is 0. F prime of 2 is negative 2. My answer is negative 2. Cool. What if it's f of x times e to the x? Product rule. F prime of 1 is negative 1. F of 1 is 3. This is 3 e's minus 1 e. I got 2 e's. All right. Is something increasing or decreasing at x equals 1? Well, if we know the slope, we'll know if it's increasing or decreasing, right? So I don't really need to do a full sign analysis, but I will. For the future, I just need the slopes. This is a product. The first piece of the product, we need to know an I. So e to the power times negative 3 is the derivative of the first times the second, plus the derivative of the second times the first. And we don't really need to factor or set this equal to 0. Just find the slope. And then we know if f is increasing or decreasing. So I got e to the negative third times negative 3 times negative 3 plus 2 e to the negative third. So this is 9 e to the negative third plus 2 e to the negative third. This is 11 e to the negative third. This is greater than 0. So f is, who you call just went into the math office to ask a question.
L.
Yes.
Thank you.
Yep. F is increasing because e to any power is always positive. Doesn't matter if the power is positive or negative. E to the negative third is the same as 1 over e cubed. That's a fraction, but it's still greater than 0. F is increasing. 11 over e cubed, y's per x's. At x equals 1. Cool. Okay. We've done this one before. It's a product. But part of the product is a chain. Slopes of the first times the second, plus the slopes of the second times the first. And let's plug in pi over 3. I get negative e to the negative pi over 3 times the sine of pi over 3. Sine of pi over 3 is root 3 over 2. How do I know the sine of pi over 3? Pi over 3, tall. Pi over 3 is a 60-degree angle. So, boom. Cosine of pi over 3 is a half. Okay. I have negative root 3 over 2 e to the negative pi over 3's plus a half e to the negative pi over 3's. Is this a positive or a negative value? Well, maybe it's helpful to factor. Maybe this is like a segue into our Sign analysis. Negative root 3 over 2 plus a half. This will always be positive. Cool. Negative root 3 over 2 is bigger than 1/2. You can see root 3 over 2 is bigger than half. The sine is bigger than the cosine, but the negative is still there, so this is actually a negative value. So we would say g is decreasing by this many y's per x, whatever that value is. Okay? All right. Moving into unit 3 and function analysis. How do you find extrema? You need to do a sign analysis of the first derivative to tell if your original function is increasing or decreasing. Common thing done is factoring. E to the x is always positive. It's never 0. I will factor out an x as well. X could equal 0. 2 plus x could equal 0. Those are my two critical points. I will examine the sign analysis. I'll have positives, negatives, positives. Plug in 3, positive, positive. This is positive. No solutions from that. It's just positive. Plug in -1, negative, positive, positive, negative. Plug in -3, negative, negative, positive, positive. So there we go. F has a max. F has a max at x equals -2. F has a min at x equals 0. Great. We did this one before. Let's do it again. Product rule. Slopes of the first, that negative is the derivative of the inside plus the second times the second plus the slopes of the second times the first. What do we like to do? Factor out the e to the x. Maybe factor out the 4 as well. Maybe we factor out a -4. Options. This will always be positive. 4 is not a solution. 0 is not a solution. You do not factor out x. We just need to figure out when negative sine x plus cosine x equals 0. We've done this enough. I hope we're comfortable with it. It's just a common one that shows up. We get sine x equals cos x. We get tan x equaling 1. So we have pi over 4 and 5 pi over 4. If I plug in 0, positive, cosine of 0 is 1, positive. If I plug in pi over 2, positive, sine of pi over 2 is going to be 1, we get negative, cosine of pi over 2 is 0, negative. 5 pi over 4, let's go to 3 pi over 2. Let's go to 2 pi. Sine 3 pi over 2 is -1. Make it negative, then it's positive 1. So this is going to be positive. So that means f is increasing, decreasing, increasing. That means x equals pi over 4 is the location of a max on f, and x equals 5 pi over 4 is a location of a min on f. Remember, we're looking at the signs of f prime to figure out when f is increasing or decreasing. Product rule. I'm not going to distribute. I'm just going to leave it like this. Slopes of the first times the second plus the slopes of the second times the first. I'm going to factor out the e to the x. How the heck do I solve this? Well, put it together and realize that you can factor this. We get -3 and 1. This is always positive. I'm going to go to like 2, positive, positive. This will be negative. This will be positive. F, increasing, decreasing, increasing. X equals -3 is a max on f. X equals 1 is a min. I want to see this because it's like, it's really cool to see it like this. really cool how the fact that the slopes of e to the x are e to the x, that helps you find locations of maxes and mins. Like it's not hard to do. It's pretty cool. Max at -3, min at 1. This is all math. All right, this one's a little trickier. Slopes of the first times the second plus the slopes of the second involve a chain, so use the chain rule correctly. Slopes of the second times the first. We need to set this equal to 0. We need to factor to solve. Cool. This will never be 0. This will always be positive. I got to figure out what 2 plus -4x squared equals 0. I get x squared equals a half. I get x equals the square root of a half. Don't forget the plus or minus. This is important to do. We did this in class. Plugging in something that's big and positive 5, well, that'll be 2 plus -4 times 25. That'll be a negative. If I plug in 0, I get that positive 2. I plug in something largely negative, square it, becomes positive times -4 becomes negative. So I actually see I have a min at negative root 1 over 2, and I have a max. Remember, root 1 over 2 is the same as 1 over root 2, which is the same as root 2 over 2. You may need to know that that's root 2 over 2. Okay, min it there and max it there. Okay, and then the final couple questions are just your first derivative and your second derivative analysis. You gotta be very careful. You gotta correctly. Don't distribute. You could distribute. I'm just gonna leave it. Just use the product rule. I'm gonna factor out the e to the x. And realize that I can combine some stuff together. And I get a 0 at -3 over 2. If I plug in 0, I'll get positives because this is always positive. If I plug in -2, I'll get negatives. Cool. Now, I am going to say that that is my derivative, and I will go ahead and take the derivative of that using the product rule. Slopes of the first times the second, plus the slopes of the second times the first, and I will factor out e to the x, and I will realize that things change for the second derivative. I can set that equal to 0 to get -5/2. -5/2 is to the left of -3/2. We'll get positives, negatives. This is my second derivative. The first derivative tells me about f. The second derivative tells me about the first derivative, which tells me about the curvature of the original function. Cool, so nothing's going away on us. When is f decreasing? Here's f decreasing. When is f concave up? Here's f concave up. So when are we doing both? We see the interval -5/2 to -3/2. And I want to see it. Here is an interval where you are actually decreasing, but you're concave up. It's just phenomenal. We're decreasing concave down, boom, point of inflection. We're decreasing concave up. It's just great. It's just great. It's great stuff, guys. It's great stuff. We're having fun. Are you not entertained? I'm entertained. I love this stuff. Every time I do it, I'm just like, oh, that's great. That's great. This one's easier. I'm going to take the derivative of this guy. I think it's easier to do. Just going to use the product rule. Slopes of the first times the second plus the slopes of the second times the first. Then I factor out an e to the x. I get 1 plus x plus 1. And then I'm going to say, oh, that's just 2 plus x. So I get negative 2. So, like, I made this homework easier than the past. I kind of made it a little bit shorter. I think it's okay, though. I think if you really understand this, you're ready to tackle anything, you know? Like, let's just make sure we can get these problems. There's a couple tricky ones out there, but nothing too crazy. Increasing concave up. Here, f is increasing. Here, f is concave up. So, from -1 to -infinity. Or x is bigger than -1. Good stuff, guys. Let's go get lunch. I'm going to go get lunch. Make sure you've done enough problems. Make sure you practice the problems that you struggled with. Copying things down means nothing. Do a couple problems for every page, and that's all I care about, okay? See you out there. Peace.